Good morning. So we usually allow about 5 minutes for folks to turn up before we get started. And let me go ahead and put the meeting minutes into the chat. If folks can go over there and add themselves to the attendee list, that's fantastic. And we'll probably be going about 5 after. And I'm just now noticing we're not even to the top of the hour yet. So for folks who are joining, we usually start about 5 after. I'll put the chat link into the chat for the meeting minutes. If you could please add yourself to the attendees list there, that would be very helpful. Thank you. Okay. Also, as a note to folks, please feel free to go ahead and add any agenda items you may have to the agenda. We generally keep a pretty open agenda as a community. And so, folks usually just add their items to that agenda. And I see folks have already done so, which is awesome. So much appreciated. And we'll get going here in a couple minutes. I'm going to give everyone a chance to arrive. For folks just arriving, I'll go ahead and put the link to the chat in to the meeting minutes in the chat. If you could go ahead and add yourself to the attendees list, that would be most helpful. Also, please feel free to add any agenda items you may have to the agenda. Okay, let me go ahead and share the agenda and we can get going. And again, there's a link in the chat for folks. So, can everyone see the agenda? Share.
I can see it.
Fantastic. So, running through it, please feel free to add yourself to the attendees list. Do you want to go ahead and run the meeting today, Frederick? I apologize, I'd forgotten because you're usually, it's been a little while, you weren't here the last time, so go ahead.
Cool. So welcome to Network Service Mesh. We host this meeting every 8 a.m. at Pacific every Tuesday. Feel free to join us as well for the developer issues and PDR meeting, which occurs every half hour before this meeting at 7:30 a.m. Pacific time on every Tuesday. We also participate in the CNCF Telecom user group. The next one will be on Monday, June 7th at 1500 UTC. The last one was canceled due to KubeCon. We also participate in the CNCF SIG network, which is getting renamed. I have to go look up what the new name is going to be. But in short, that's going to be, that is on every first and third Thursday of the month at 11 a.m. Pacific. And all of the details are on the on the document. We also have we've also just completed KubeCon, so there were several interesting talks, but I wanted to also point out the keynote that was given by Cisco did cover network service mesh as a major theme. They also pitched the idea of service meshes for other types of things as well. It's so definitely worth watching. KubeCon North America CFPs are currently open. They close on Sunday, May 23rd. Also, Open Networking and Edge Summit, which is going to also occur in Los Angeles. That both KubeCon North America and Los Angeles are in, or sorry, KubeCon North America and ONES North America are going to be on Los Angeles, and they're going to be almost on the same day. They have one day where they overlap, so they were scheduled to be back to back. And
please be aware when we say in Los Angeles, I don't know about ONES, but I do know that KubeCon is going to be explicitly a hybrid event, because we don't know, we do believe that some folks will be able to travel to KubeCon North America in person, but we also know that will not be true of everyone. So if you have a talk proposal you want to submit to KubeCon, please, even if you don't think you're going to be able to travel, there will be accommodations made for remote presenters, because there's going to be a lot of them.
Absolutely, and one of the nice things about the KubeCon ones is that they almost always tend to be recorded and put on YouTube live for others to see afterwards. So, which is a huge bonus. We also have so the CFP for that one as well, I believe, is on the same day, May 23rd. With that, in terms of major events, I don't know of any other major events that are coming up, but we will continue to post them as we find them. In terms of our social media community team, we have added 29 followers and are following 74, so pretty big week. We sent out 31 tweets. We also have posted, we also post all the information on LinkedIn as well. There were no changes on LinkedIn this particular week. And in terms of in terms of that, we head on towards our agenda. So the first item on the list is multi-IP for IPv4 and IPv6 implementation. The implementation is now complete. So Ed, do you want to take this one?
Sure. So just a really quick background here. We've had a long-standing request for dual stack support for network service mesh, which, dual stack being defined as being able to have both IPv4 and IPv6 addresses. And we've also had use cases that have come up historically where people wanted to be able to provide, in addition to issuing a unique IP, they wanted to be able to provide a VIP IP for something so that it could respond to a load balancer in a reasonable way with direct server return. And both of which are fantastic use cases. And so this has been out there for, frankly, too long. And so finally, we got to the point where instead of having dest IP address and source IP address, you have dest IP addresses and source IP addresses in the API. So you could include multiple IP addresses. And basically those come in from both both IPv4 and v6 are supported there. In the course of this, we sort of discovered a whole lot of weirdness in the Linux kernel IPv6 stack. There be dragons, but we've also discovered the fixes for them. So tire kicking here would be very, very welcome on this. Now, the other thing that would be really useful, and I won't spend too much time on this, is that there were a certain number of presumptions that we ended up having to make that I wanted to make sure were not going to be necessarily problematic. So for example, there are places where you have IP addresses on, so typically right now in network service mesh, if I give you a bunch of source IP addresses and a bunch of dest IP addresses, it's possible that those source or dest IP addresses could be /32s. If they're /32s, obviously you don't get the sort of default networking that comes from having overlapping subnets between your source and your destination. And so in the case where I have a source IP address that doesn't overlap with at least some destination IP address, then I basically presume that we need to insert a route, and the next hop address that I will use for that route to acquire the Ethernet MAC address, in the case of Ethernet payloads, is going to be the first address of the same family, whether that's v4 or v6. So, that's all stuff that is sort of going on in there as well. So there are lots of little nits that you could discover when you go to kick the tires. Do folks have any comments or questions about the multi-IP support? Don't all speak at once.
Yeah, so we will try to check it out. Sounds really interesting.
Yeah, it hopefully works out really nicely. So one of the other things, by the way, that came as a result of this is because you now have multiple dest IPs, you also have the option for routes that are passed back of specifying a next hop IP. So if you are passing back routes as well, you can now provide an explicit next hop.
All right, cool.
Mm-hmm.
Yet, do we have IPv6 IPAM support available with the endpoint? So that is basically.
You're very faint. Could you speak up a little?
No. Do you have like IPAM support available for IPv6 as part of this NSC implementation?
So I'm trying to remember if we do so basically we have right now, please note in network service mesh, IPAM is a pluggable feature for your NSC because the NSC is the one who's in charge. And we have right now what we refer to as point-to-point IPAM, which is basically just handing out /32s from one or more from some number of prefixes. You could do it other ways. It just happens to be the one that we've done for an example. Now, the point-to-point IPAM has for a while now supported IPv6, so you could use IPv6 addresses in the point-to-point IPAM. What's changed now in point-to-point IPAM is that I put in some changes that allow you to stack multiple point-to-point IPAM chain elements. So if you were, for example, go look at the command forwarder testing, you'll discover that the network service endpoints that were sort of built for testing in the command forwarder repo, as part of that testing, they have two instances of point-to-point IPAM in their chains. One has a v4 prefix and the other has a v6 prefix, and so it issues two IP addresses, one from the v4 and one from the v6. Does that answer your question, or?
Yeah, sure. No, basically, like, let us say, like, if we are going to implement our own endpoint, maybe that needs some IPv6 based IPAM. Maybe if it is part of some SDK, maybe we can just reuse it. Like,
But that's what I was
some-
saying, is in the SDK, there's a
Oh,
point-to-point IPAM
Okay, okay,
module.
okay, okay.
And please note, if you discover other kinds of IPAM that you think are generically useful, we actually would welcome having more IPAM modules in the SDK, because right now the point-to-point IPAM is very specific. It basically gives both ends of the connection a /32 out of a prefix pool. Obviously, that's super useful in some circumstances and not at all helpful in others. So if you have other kinds of IPAM that you want to do generically, that's actually probably a really good starter project in the SDK.
Yeah, in fact, with the IPAM, we decompose the IPAM into multiple parts as well. So you have the part that actually does the signing of the address, and you can swap that out for other things. But other things that people tend to think of as being important in an IPAM, things like how do you journal what IP address was done. So in case if the system fails, then you have a way to replay it or to tie it into your observability or so on, is set up as a separate as a separate thing. So you can implement the part of your IPAM that you care about and still leverage the rest of the IPAM system, the rest of the IPAM mechanism, in order to integrate with the system. And if you don't like the journaling that we provide, you can swap that out as well. So there's a lot of flexibility here in terms of how you can implement it, but it's also designed to be composable.
Okay.
And please note, if you reach out over Slack, any number of folks would be perfectly delighted to give you exact pointers into GitHub to this is where this is where that is, that kind of stuff. But it's intended to be super easy. It's intended to be a super easy process.
Yeah, and the reason that we went with a point-to-point IPAM for the initial version is that from a scalability perspective, it allows us to assign things that are local in nature. So when you assign IP addresses, you can either assign them to be global or you can assign them to be local in scope. And so these are designed to be local in scope. So you don't need to deconflict everything. You just need to make sure that the IP address you choose is not being used by the two workloads that need to need to consume them and their immediate neighbors. And that allows us to reuse IP addresses. So in the case of IPv4, it allows us to reuse, like we can give a link local address as an example and use that. And we can reuse that address over and over without fear that we're going to break something. Of course, this is not useful in other major areas, but when you're doing a point-to-point connection where you just need to make sure the two workloads are able to communicate with each other, then it sidesteps the entire which 10.x, which 172 or 192 or other IP addresses should I not conflict with.
So one of the things, Perry, by the way, is that the /32 point-to-point IPAM is sort of very opinionated about IP payloads, because obviously it's not going to help you if your payload is Ethernet. If you're doing something like bridging, then /32s are not going to be very helpful. But the bridging case, the Ethernet case, is a real case, and so maybe an IPAM that would assign, out of that basically would assign sort of larger chunks to a bridge domain might be of interest in that kind of thing.
Yeah, that is correct.
So awesome. Look forward to chatting with you on IAM. Anything else on the multi-IP stuff?
Cool.
All
so
right. Good.
So I was going to move the meeting forward, but yeah, let's jump in.
Okay. So the next thing up is we're getting to the point where we should probably be talking about doing a release. And so I put this slide out here basically as just a conversation point more than anything. So all of this is certainly open to discussion here in the community. So think of these as just stakes in the ground. So we have our annual review coming up in June. And so what I would suggest is that we target a release date around June 8th in order to get the 1.0 release out. Because I think we're getting to the point with the refactoring where we can actually have something releasable here. My proposed feature list, and please note this is in priority order in my own head. So this is totally open to discussion. And these are sort of the big rock pieces. We still need a remote payload mechanism for IP payloads, or remote mechanism for IP payloads. We have one for Ethernet, that's VXLAN. And I would love to be able to get WireGuard out as the payload mechanism for IP by default. But if we don't manage to achieve that, then we could fall back to using something like VXLAN GPE. For those of you who don't know, VXLAN only carries Ethernet frames. VXLAN GPE can carry any kind of a next payload that you might want, including just carrying the IP packet. Interdomain and floating interdomain, in my mind, are super crucial features. We've got the P2P and P2MP enhancements that we discussed previously. And then some of the scale from zero work would be really nice to get out.
It would probably be good to give a quick description of floating interdomain versus a regular interdomain.
Sure, that's actually a good point. So basically, interdomain is the generic concept that in network service mesh, you have different domains that network service endpoints register in, and that clients can ask for a network service from. So for example, I might ask for database replication at finance.example.com as my network service. And finance.example.com in that case is a network service domain, and it may be under entirely different administration than, say, the local domain in my cluster. And it could be, NSEs in my cluster could register themselves with that domain as providing a network service, and clients can consume network services from that domain, even if they're running in different clusters and different clouds, on-prem, et cetera. That's the basic concept of interdomain. But it turns out, normally when we turn the crank on interdomain, it's, the first turn of the crank is trying to talk between the domains running in two different clusters. But the really interesting one is what we call floating interdomain. And the idea with floating interdomain is that you have a network service mesh domain that is not actually connected to any runtime domain at all. So its NSEs will run in whatever clusters they're needed in. They will talk to each other to string together whatever network service is needed. Clients can run in whatever cluster, whatever cloud, on-prem, et cetera, they need, and connect to a common network service in that floating network service domain. Does that make sense to folks? I don't know if I did a good job of explaining that or not. Any questions?
Yeah, I think we're probably good. So
cool. And then the point to multi-point enhancements, this was the discussion that Jan had brought to us a couple of weeks ago. And I would really like to get that in. We'll have to see because time is tight. And then the scale from zero enhancements. Scale from zero enhancements are basically the observation that it's relatively easy in network service mesh to scale network service endpoints from zero. So the example I will often offer for this is, let's say that I have a virtual bridge domain network service, and I would like there to be an instance of the virtual bridge domain running on each node for which there is a client, just because it turns out to have advantages. Well, I don't want to go and run a daemon set across a 5,000 node cluster that puts a virtual bridge domain NSE on every node in the cluster. That's probably not the right thing. But it turns out that you can do a very clever thing with network service mesh by having having a match that first tries to match topologically to your node, if there's a network service running there. And if not, it falls through to a catch-all that would then send the request to an entity that would spawn that network service endpoint on your node and then return an error, which would cause you to try again. Now that the network service endpoint is running on your node and therefore would match when you went to look it up again. And then you could have the NSE that spawned on your node effectively just kill itself if it goes some period of time, like say 10 minutes, without having any connections. And in this way, you can scale up and down from 0 in terms of the network service endpoints that are providing the network services that you need. And that's a really, really cool possibility with network service mesh that we'd really like to see as well. Any questions on the scale from 0? Cool. So then sort of my proposed testing priorities, and I sort of list them out in what's in my mind the priority order is. The first is getting the packet GKE, AKS, EKS testing going. A lot of this is in progress. We've got packet and kind going right now. I think GKE is coming together. AKS and EKS are coming together. We've uncovered some bugs in the course of this that are getting fixed. But this way we actually know we run on a pretty broad array of environments. Composition testing. So the network service mesh has a rich composition feature. It's sort of akin to what the networking folks think of as service function chaining. And we don't currently have any of the testing for that in the multi-repo. And I know that there's actually work underway for that. Actually, there's work underway for most of these items. Like, so when I sort of list them out as priorities, it's not like they're not already in progress. Chaos testing, meaning sort of testing the healing test cases, is also something that's in progress that I think is an important thing. And then performance testing, scalability testing. Obviously, I tend to think of performance as data plane. And this uncovers issues like we've recently put some features in for MTU discovery, because as everyone knows, fragmentation leads to horrific performance. And if you can figure out sort of the MTU for the chains for the virtual wires, you can do quite a bit better. Scalability testing is more the scalability of the control plane. And continuous upgrade testing is more of, okay, can we actually continuously upgrade the system and have the network service endpoints continue going? And that's sort of the idea priority-wise there. There's some things that we need for release mechanics. So we definitely need new and improved documentation. And maybe it makes sense to put a lot of that on the website as opposed to in individual repos. I think the individual repos are good places for sort of developer documentation that's local to those things, but the website is a good place to put sort of the pulling together documentation potentially. And then, as we'll see when we get to the release repo proposal, we also need a place to pull all the pieces together for an actual release, and the release repo is one way to do that. And then my suggestion is that we do, after that, a proposed future cadence release of quarterly, which would roughly put the next release around August 31st if we go quarterly. Now I realize there's a lot here, but most of these things are actually already in flight. So it's just a matter of them landing. So do folks have questions, comments, places where they feel that things have been left out or that they would like to see things moved up in priority? Because my thinking is that if you're trying to hit a date, typically you try and work through your priority list, and there may be some things that fall below the line, but you'd like to try and get through as much as you can. Please note, by the way, that in an open source community, different people have different priorities and direct where they put their work effort. So there's no one unified priority list. This is just sort of what's going through my head. So thoughts from folks?
Ed, can you hear me? This is Jan speaking.
I can.
Okay, great. I was not sure my micro was working. I'm positively surprised to see point-to-multipoint enhancements on the candidate list here. I was wondering what you include with this, both the changes that we discussed, the moving the endpoint selection from manager to forwarder, or the forwarder selection, or both. So
let me sort of explain why, at least in my mind, I had this on the list. And you'll note that it's not high on the list, but it's on the list. And the reason in my mind I personally wanted this on the list is there's a certain foundation setting with release 1.0, where I would like to make sure that we get the API sort of as solidified as we can. And the selection stuff would imply an API change. So it would be very positive in my mind to get that in before we go out the door. And then also, it's a very fundamental change in flow where we no longer double loop through the network service manager, which I think, in addition to making the point-to-multipoint enhancement possible, should also greatly simplify the network service manager. And of course, any simplifications reduce bugs, also reduce latency, that sort of stuff. So I would really like to get it in, and this is sort of like, I think, second on my personal list of things I'm going to go take a hand in moving the code forward for. And that's why it's on the list. Plus, correct me if I'm wrong, Jan, but I think this is the last of the things from the Ericsson wish list that we haven't delivered currently.
Yeah, we were discussing just today the VLAN breakout case, where we are currently working on a kind of special purpose forwarder to be able to do this, and that would also require a forwarder selection mechanism in place in order to upstream this properly. So from that perspective, it would be great if we could have the forwarder selection included. For sure.
In my mind, the forwarder selection is something I'd like to include in the point-to-multipoint because it requires an API change. And I'm sure that the API will not be set in stone. That's part of the point of using WireGuard. But I'd like to get the API as settled as we can going into the 1.0 release.
Okay.
So
yeah, sounds good.
Okay. So I guess the question then becomes, yeah, so this is basically what was going through my mind. I'm curious for other questions, comments, differences in opinion about priority, et cetera. Don't all speak at once.
Yeah, so I think this is overall very good. The two main items that we have with remote IP and interdomain, even if we just got those two in, I would say that would be worthy of a 1.0 release. Of course, the more the merrier. Yeah, I think getting this into a position where we have that and we have the testing in place to demonstrate that it continues to work over time, I think would be very powerful.
Well, and one other thing to keep in mind, this is sort of when I list out the features and priorities, a lot of this it's not the complete feature list that goes out the door. It's just the stuff that we still need to close on. So, for example, we've already got some amazing things working, like the Markdown-driven testing, which is incredible because it means literally your documentation becomes the test that you write. We've already got things working like SRIOV support, both for VFIO and for kernel interfaces. That's been working for a while and continues to work. So we've got a lot of really interesting things already in the system that we didn't have before that I think people are going to be interested and excited about. And I think where the rubber is really going to start hitting the road is as we start hitting that quarterly cadence going forward, where more stuff is going to start coming out of the woodwork. Cool. Anything else on this? Otherwise, I will yield back the floor.
Okay,
so okay, there we go. Yeah.
We have the release repository proposal. So if we can open up the link on there.
Denise, do you want to talk to this, and would you like to share for this one?
Yes, hello. Could you please open just the document?
Sure.
So, in short, this document about point from NSM release 1.0 It's about continuous upgrade testing and about NSM release repository. So the current state of our multi-repo pipeline allows testing NSM on different integration platforms like GKA, AKS, and so on. And this document about what we should do if all testing in each integration platform repository has passed. In short, if we tested a set of Docker images with some version, we need to move them from our Docker Hub into public Docker Hub with latest tag, as we do in a monorepo on PR merge. In other words, main idea to create a final repository for the repo pipeline that will move Docker images from private to public repository when all testing has passed. Also, the repository will allow to tag the latest images in public Docker Hub by some tag. So, for example, we can just create or push a new tag into the NSM release repository, and then GitHub will schedule the job that will add the tags for all latest images in the public Docker Hub. So, and finally, when we will release the tag, the NSM release repository will schedule the second job that will run continuous upgrade testing. So the job should verify that if we updated one of the applications of NSM from the previous to the latest version, then all NSM use cases still working. For example, if the job with continuous update testing will fail, then we'll think about what we can add or modify in the latest NSM changes to make it compatible with the previous versions. So mostly that's it.
Cool. And part of the reason I added this to the agenda is that this sort of gets to the question of how do we pull together the release pieces in one place once we've run them through the pipeline.
So for this, we could add GitHub workflow. So actually, our integration platform repositories testing do testing with some specific version of deployments Kubernetes repository. So to make to get a set of all tested images, we need only to create some workflow behavior. For example, if release repository got a few labels from the previous repositories, for example, from integration Kubernetes GKA, then it merges the PR into the release repository, and it just moves all tested images into the public Docker Hub with the latest tag.
Okay. Cool. Do folks have questions, comments, thoughts? All right, thank you.
So in terms of the OVS forwarder, so who put that on the list?
It was me, Jan.
Fantastic. You have the floor.
Okay. Let me share my screen.
Let me stop sharing then. There we go.
Okay. So let me know when you can, if you can see something.
Not seeing the share yet.
No, okay. No.
Still not seeing the share yet.
Okay.
Are you having?
Yeah.
Okay, now I'm
It's
seeing
coming.
something.
I had some problems picking
Happens.
the right source here. Okay, good. I wanted to give you an update on the OVS forwarder front. You may remember that we presented this a long time ago in July last year. But it's not that nothing has happened since then. So it's time to give you an update. I just want to do a very quick recap, motivation and main idea that has driven us to do this. We were looking at the existing NSM forwarders. At that time, it was kernel forwarder and VPP forwarder. And they have all their merits, but they also have limitations that are relevant for the use case we're looking at. Kernel forwarder, particularly the low performance, no support for user space implementations in network service clients and endpoints. VPP having support for those, but still only having a DPDK data path with moderate performance, packet copying cost, dedicated CPUs. That led us to looking at an alternative, using Open vSwitch, OVS, as a data path with its inherent capability to offload the data path to a SmartNIC, overcoming all these limitations. Now, with the next-gen NSM, the situation has slightly changed. The kernel forwarder is not really there yet. VPP is there, but the characteristics are basically still the same. There's a new forwarder, SIV forwarder, which basically gives PCI pass-through performance, but it has all the inherent problems with legacy SRIV. Right, we can only cross-connect to VLANs. There's no link redundancy, and so on. So it's too primitive for our perspective. So all the reasons for going for OVS forwarder with SmartNIC data plane are still the same. We can support kernel and user space implementations. We have full PCI pass-through performance without packet copying, and we are no host CPUs consumed. So quick recap. This was work that was done by our Ericsson software technology colleagues who are able to work upstream. And the work was done on the Nordics fork of the monorepo network service mesh in 2020. And we had a first presentation of the project in July. The link is here in case you're interested. I'm not going to repeat all the details. And some of the details are, of course, now a bit out of date. We have continued to work with this in-house, and we did a real POC using this data plane in Q4. And you can see a sketch of this here. We had a load balancer implemented, a DPDK load balancer implemented based on VPP, running on top of OVS forwarder with offload to SmartNIC. And then we had application network service client bots terminating the traffic. All DPDK applications, of course. And what we could show here is that we had something like 30 million packets per second bidirectional coming in on the VLAN here, being load balanced between the workers and out again. So this was highly successful. And the intention is to upstream this, but we parked that effort until the next gen NSM was ready. And I don't want to go through the details again here because not all of this is relevant. But one of the things that I want to point out is that in our original solution, we were relying on the SRE network device plugin for managing the SRE virtual functions that we call smart virtual functions when they are virtual functions of a SmartNIC. That is relevant because that part will change now that we are going to next-gen NSM. So the work to actually uplift this has started a couple of weeks back. Peri is doing it, and it's progressing quite well. We will have support both for normal VTH link kernel interfaces as well as smart virtual functions. Both will be using kernel as local mechanism, and the choice whether it's going to be a VTH pair or a smart virtual function is on the presence of an SRV token. And you can see that we have adopted the new device plugin in NSM to manage SRE virtual functions. We believe this can be used as is for our use case. And we are going to support two flavors. One that comes with its own OVS, standalone, deployed with the OVS forwarder to make it simple to deploy. And then another one that is more complicated to deploy but more useful in production environments is where we have an OVS installed on the node, and NSM can share it, the OVS forwarder, with other users like OVS CNI or other OVS-based data planes for Kubernetes. The work is ongoing, progressing very well, I would say. It's still in the private GitHub repo. The reason is that we are dependent on some upstream SDK code enhancements and changes that Peri will talk about in a minute. So we would rather do these things first before we then make OVS forwarder public that can consume those. And then, of course, we will make it public in Nordics repo and then send the pull request to actually move it upstream.
Fantastic.
Okay, so Peri, please take over. I think you're a better position to explain how the new architecture looks like and how it relates to the next-gen NSM repositories.
Okay, thanks, Jan. Yeah, so basically, this is the runtime view of the OVS forwarder endpoint. So that is going to be based on the new NSM framework. So basically, if you just look at this diagram, so this is almost same as SRIOV forwarder endpoint. So that is available in the upstream. So that is because we are going to make use of the resource pool and the token ID pool. So that is basically a device plugin server that is going to run along with the forwarder. So we are just going to reuse those components in the OVS forwarder to manage all the smart VFs. So that is the reason, like, this is almost same as SRIOV forwarder. But along with that, like, we also support the kernel data path via with pair connections between client and endpoint. And for managing the VFs, so we basically provide all the configuration via this file, SRIOV config file. So that has all the PF and VF configurations along with the service domain and the capability details. So that is the input towards the token ID pool component. So that is going to create the pool of IDs, that is UIDs for all the VFs. And those IDs are going to be exposed to the Kubernetes via Kubelet device manager. So that is for scheduling purposes. So along with that, like, we also have another gRPC endpoint that is towards the NSM manager. So that is basically to receive and send the service request. And along with that, like, as part of this OVS forwarder, like, we also install Open vSwitch that is going to be installed along with the pod. So on that, like, we are going to create an OVS bridge that is called BRNSM. So on that, like, we are going to create the required OVS ports to cross connect the client and endpoint.
Yeah, so I think this is the picture that would illustrate that part. It's part of the slide deck that we will publish and make the link available so you can have a look.
Quick question, Peri, and this is sort of for I have a standing concern about making sure that everything we do is easy to reuse and reconsume. And so I'm extremely pleased that you are reusing the work that was done for the SRIOV forwarder here. How's that working? Are you finding the chain elements to be relatively reusable as they are? Like how is all of that going?
Yeah, actually, from the implementation perspective, like so we are seeing few things can be moved into SDK SRIOV. Maybe if we move to the next slide, we can discuss a bit more. So basically, right now, like if you look at the resource pool implementation, so that is available only for the client, but that is not available for endpoint. Maybe if we try to make it to work for endpoint, so then we can reuse the code at maximum level. Because right now, like I am just making a copy of this resource pool into CMD forwarder OVS, so that it can be available to endpoint. Maybe that is where we have to make some enhancement. And also, like we have the device plugin server. So right now that is part of CMD forwarder SRIOV repo. And also that is moreover a internal package. Maybe that also if we move into SDK SRIOV, so that can be used from OVS forwarder. So these are all the two changes with respect to SDK SRIOV. And then if you look at
Vlad, do you have thoughts on these? The reason I'm asking Perry is Vlad's the one who implemented the code originally.
I guess there can be some problem with moving device plugin server to SDK SRV repo because it has some dependencies on K8s repo, SDK K8s repo.
So we may need to put the device plugin into its own repo. I actually completely agree with your assessment there, Vlad. But I think the real thing you're looking for, Perry, is you would like a modular resource device plugin that you can just pull into the thing you're doing, correct?
Yeah, so we have all the relevant APIs available from this device plugin server. So only thing is we need to depend on this repo, the CMD forwarder SRIOV repo. And also it's kind of internal package, like, so that is the problem we have.
Well, the thing is that the reason that most of the things that command stuff are internal packages is that if in fact there's code in there that you want to reuse, we should really break that off into a proper thing that from which you should import dependencies, because importing command repos are intended to be leaf repos. And so it's fantastic that you found it to be something you want to reuse. We just need to figure out, and this is possibly another conversation we should take to Slack. We need to figure out sort of like where to put it in a reusable place. Because I don't think having you import from command forwarder SRIOV is the right answer.
Yes.
We have SDK Kubernetes or Kubernetes stuff. Probably we could move resource pool into SDK Kubernetes.
So it's entirely possible. Like part of it is you just need to look at, one of the things you may have noticed, Perry, is we're very careful in terms of keeping dependencies lean in the system. So we try not to produce situations where, like, for example, the SDK VPP pulls in a bunch of VPP dependencies, but it doesn't pull in, but you know, SDK SRIOV doesn't pull in VPP dependencies, right? Because there's no reason why you would need them necessarily for SRIOV. So we just need to figure out what the right placement for the device plugin server looks like.
Yeah, and also we have this resource pool implementation that is available only for the client. So we have to make it available for endpoint so that we should be able to inject VF into endpoints.
Yeah. And so the other thing I would actually suggest to you, Perry, is that, well, two things I would suggest, right? The first one is to think about timing wise when you would want to factor these things out upstream, keeping in mind that we are probably looking at doing the release June 8th. And then we're considering doing a follow-up release August 31st, I think. Because I'd like to put you into the best position to upstream the changes you need and to be able to get something, presuming that that's what you want, in public for this forwarder. And this may be more a question for Jan. On the OVS SmartNIC forwarder that you're talking about here, Jan, when you're talking about upstreaming that, are you wanting to put that publicly in a repo that's a part of the Nordics GitHub organization? Or were you wanting to upstream that as a separate command forwarder repo in Network Service Mesh?
we're thinking this is a two-stage approach. It'll first go into Nordics repo, and then from there we can hopefully make it a repo in NSM.
Okay, no, that's fantastic. The fact that you're wanting to go first to Nordics means that I'm also sort of wondering if we want to be in a position where we can, from Network Service Mesh, sort of point to work that is out there that is not necessarily in the Network Service Mesh repo, in some of our documentation, in some of our release notes, that kind of stuff. Because just for the sake of argument, say that the ambitious thing happens and we manage to get some of this stuff done for the, we get this all done for the August 31st release, but you're not quite ready to move the Nordics repo up into Network Service Mesh at that time. I think it's positive both for the work you're doing and for the broader NSM community to be able to point to the broader space of work that's being done, whether it's in the Network Service Mesh organization or not. So that being said, I do want to be clear that like having another forwarder in the Network Service Mesh organization would certainly be a good and welcome thing.
Yeah, okay, sounds good. And I mean, also targeting first release of this in the end of August or beginning of September sounds like a reasonable aim from my perspective.
Well, and it also positions you very well because then you would have it out there and released in time for doing talks at KubeCon and ONES and that sort of thing.
Mm-hmm.
So, but yeah, that all sounds fantastic. I apologize, Perry, I interrupted you in the middle of what you were saying. Do continue.
Yeah. Apart from this changes into SDK SRIOV, we also need to make some changes into SDK kernel. So because if you just look at SDK kernel, like we have the IP context package, so that is available to configure IP address and routes for the clients, but that is not there for endpoint. So maybe that there we need to make some changes so that we can reuse the code. The same kind of implementation is available in SDK VPP. So that is also used to configure IP address and routes on the kernel interface that is created inside the container. So maybe we can have some converge on this aspect.
Well, let's definitely have some conversations on that because among other things, there's some things that have grown up in SDK VPP around setting what I call sort of the connection context kernel stuff.
Yeah, correct. Yeah.
And that's grown up independently of the SDK kernel bits. And logically speaking, probably those should live in SDK kernel. And so talking about what that looks like is probably a good idea.
Yeah. And apart from that, like we use VXLAN as the remote mechanism in OVS forwarder. So for that purpose, we have to use the VXLAN VNI client and server. So basically that is already there as part of SDK VPP. So I'm not sure, like either we can just directly reuse from SDK VPP, or we can move this implementation into SDK repo and we can reuse.
Yeah, I'm completely open to having the conversation about moving it into the SDK repo. If you see things in SDK VPP that you think should be generalized in SDK, or that you think probably more properly belong in SDK kernel, the likelihood is that that's probably true. So definitely open to those conversations. Part of it was just the trying to get something done and out expeditiously. And I presume you're talking about the VNI client and server. This is like literally the piece that does VNI selection.
Yes, correct. Yeah. So that is so common for any forwarder. Yeah.
Yeah, and certain aspects of that do get moved into the supporting libraries for API, but not the chain elements themselves because they don't belong there. So no, totally open to that.
Yeah, maybe before I start working on each item, maybe I can have some offline discussion with you.
Let's get them queued up. We'll have the offline discussions on Slack. Let's get some issues queued up as well. One of the nice things about issues is they make what's going on more publicly visible in some ways, and more trackable. Because, for example, we could then talk about it in our weekly issue PR meetings as well, and sort of see how that goes. Now, there's going to be a little bit of discussion about the timing of the stuff, given that we're trying to get a release out. And what that really comes down to is commitment in terms of your time. because if we're going to pick up and move the stuff, that move has got to be finished and stabilized in time for the release. But it's actually good to get that done before the release, if in fact that's a doable thing, because that way we sort of have a more stable system going forward after the release. Right? You don't wind up with people who depend on the stuff in SDK VPP when it's been moved in the next release. Does that make sense?
Yeah, sure.
But this is actually super exciting, and so the changes in terms of the device plugin, that all went very smoothly for you, other than the fact you had to copy some code around. So that's been going well.
I don't get your question.
Let's take it to Slack. I apologize. I do have a meeting coming up right after this one. We are right up against the top of the hour.
Okay.
Is there
okay,
anything
sure.
else before we close, or?
No, I think we're done.
Fantastic. This is great news.
I got one last thing, something that we should have done a while ago. There is a CNF working group that Taylor and I are heavily involved with. So if that occurs every Monday at around 8 a.m. Pacific, we're adding the details to the Google document. But in the meantime, if you want to get involved in that on that CNF working group, feel free to ping me or Taylor, and we'll help you get in as well. With that, that comes to the end of our agenda. If there's anything you would like to talk about, please don't hesitate to reach out to us. Please do not hesitate to add something to the agenda. We can always shuffle the agenda around if for some reason you don't make it to the next meeting or so on. So don't feel like you can't put anything up there. Anyways, with that, thank you very much, and we will see you all again next week. Take care.
All right. Talk to you later.
Thanks. Bye.
Thank you. Bye-bye.